Homework number 11. For the first two sections, you'll solve equations by using the space provided. When solving an equation with variables on both sides, be sure that you move the variables so that there is still an item or term left on one side. For example, if I subtract 4m from both sides, that means that my right side would be completely empty. And that is not helpful. So let's remove the 6m from the left side by subtracting it equally on both sides. This leaves us a two-sided equation with constants on one side and variable terms on the other. Now we can solve for m. And on a separate sheet of paper, you can check your response. You check your response by rewriting your original equation and erasing and replacing the variable letters with the answer that you found. So a -5 in both locations, and then you can pick up your calculator and compute each side separately. So for us, we would compute 6 times -5, or I type it exactly how I see it, with the parentheses. So I got a -20 on the left-hand side, and then on the right-hand side, 4 times -5 in parentheses as well. And if the two numbers match, the answer checks. Let's take a look at question 2. Again, look carefully at your sides, and if you only have one item, you can't use that side. So we need to subtract either 36 or 6x. How we choose is depending on what's over here. So if this term has a variable, then we should use the inverse of the variable term, leaving us with 12x equals 36. Divide by the coefficient, and then check your work. I'm going to move on. For question number 3, this side has more terms, so this is the side I will choose my inverse operation from. This side has a variable, therefore I am going to subtract 9d from both sides. Divide by the coefficient, and if your term here, -13 divided by 9, is not an integer or whole number, as we can see on the calculator here, -13 divided by 9, it's not a whole integer, so we're going to leave it in fraction form, just like that. Question number 4. Again, the side with more items or terms, the left side, is the side you will choose from. Because the right side has a variable, I'm going to subtract t from both sides. Now remember, if you don't see a coefficient, it is a 1. So 4t, subtract 1t is 3t, and on the left, I'm left with a -15. Divide by my coefficient, and get my response. On a separate piece of paper, you should check your work. Now for question number 5, both sides have 2 terms. And when both sides have the same amount of terms, it doesn't matter. You can do the opposite of any term you want. I think I'm going to subtract 7p from both sides because I like my variables on the left. But you don't have to do that. You might solve yours a different way. Now my only choice is to add 4 to both sides because the left side has more terms. Divide by the coefficient and check your response. Again, same thing on number 6. I have 2 terms on the left, 2 unlike terms on the right, so it doesn't matter who I choose. Again, I prefer my variables on the left, so I'm going to subtract 7w from both sides. Now I'm going to add 5 to both sides. And divide by my coefficient. Don't forget to check your work when you're done. All right, second box, same as the first. Use your inverse operations to compute. This time, I'm actually going to add 7h to the right because this will keep my variable positive. So instead of getting a negative 8, I'm going to get a positive 8h on the right side. Now I have to subtract 4 from both sides. And now I'm going to divide by 8. Now this one isn't bad. When you divide 12 by 8, you get a nice decimal. So this one, you're allowed to convert to a decimal if you like. Otherwise, you can use your fraction button and you can reduce the fraction into simplest form. So either one of those answers is correct. So depending on if it's a multiple choice question, you would choose 1.5 or 3/2. Moving on to question number 8 now. I'm going to do the same thing. I'm going to leave my f positive. So I'm going to add 3f to both sides. And that gives me a letter on the left, but I don't mind. I'm going to add 4 to both sides, giving me 12 is equal to 4f. And divide both sides by 4 and get f is equal to 3. Okay, last one. I'm going to add 12y to both sides. You could minus 9y if you like. That gives me 15 is equal to 21y minus 6. I'm going to add 6 to both sides, giving me 21 equals 21y, and then divide both sides by the coefficient, and I get y is equal to 1. Last 3. I'm going to add 6x to both sides. I'm going to add 24 because my right side only has constants, so all the constants should be on the right. Let's see, 30, 40, and then divide by 10, and get my final answer and do a check. This one has some decimals in it, but that's okay because you can use a calculator. Whoops. You can't add 78 because this item has a variable. So that means I have to subtract 1.4a from both sides, leaving me with negative 78 equals 2.6a. Next step, divide by the coefficient, 2.6. Pick up my calculator and type negative 78 divided by 2.6 equals negative 30. So negative 30 is equal to a. And this one I'm going to show you the check step again. You take your variable from your original equation and you remove it, erase it, and replace it with your answer. Then you pick up your calculator and you check both sides. So 1.4 times negative 30, parentheses, minus 78 is negative 120. And then the right side, 4 times negative 30. Excellent. So we got negative 120 equals negative 120, and that check step computes. Okay, last one. When I look at my two sides of the equation, I see that the right-hand side has a variable, so that means that I would need to add v to both sides. That leaves me with 12.6 equals 6v. Divide both sides by the coefficient. Use a calculator if you need to. 2.1. All right, let's take a look at the next section. Graph the following linear equations using their slope and y-intercept. So the slope of the number is the coefficient of x, and the slope is the ratio of the change in y over the change in x, known as the rise and the run. The y-intercept is the constant, and that's where you cross the y-axis or where you begin graphing. So we're going to begin graphing at -9. That's right down here. And then we're going to draw other points by following the rise and the run directions. So we're going to rise +1, run +4. Make a point. Rise 1, run 4. Make a point. Rise 1, run 4. We can't run 4, so we're going to stop drawing because we've run out of space. And now I'm going to reverse it. Instead of +1 and +4, I'm going to go -1 and -4. That allows me to draw a little bit more of the line along the bottom half. Label your line, and you're done. Now let's take a look at question number 14. Again, the slope is the coefficient of x. So slope is a fraction, and if you don't have a fraction, you put a 1 in the denominator. That's what's going to tell you your two directions of how to move, rise and run. Your y-intercept is the constant at the end of the equation. So 4 is our y-intercept. We draw a point there. Now we're going to rise -3, -1, -2, -3, run +1. Down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, we're off the graph, so we're going to stop counting. And now we're going to reverse it. +3 and -1. 1, 2, 3, -1. 1, 2, 3, -1. And that allows us to draw the other half of the line. Label your line, and now you're done. The final box asks you to find the rate of change from a story. The graph shows the elevation above sea level as measured over a 60-minute hike shown to the right to answer the following questions. So we're going to use this graph here to calculate our rate of change or slope. The first question asks us to find the rate of change from 10 minutes to 20 minutes. And that would be from 10 to 20, right here. So we want to calculate the slope of that line. And we can do it by looking at the change in the y numbers and the change in the x numbers, right? Delta y over delta x. So it looks like the y values go up one box, but the boxes go by 5s. So we went from 5 to 10. So that's a difference of increasing 5. And now when we look at the x value here, we see we go from 10 to 20. So that's a change in x of 10. So the answer here is 5 over 10, also known as 1/2. Now what we need to do is use our labels to label our fraction. So the y label is what we put in the numerator. So 1 foot per 2 minutes. 1 foot every 2 minutes. Now, that's the rate. It's not the unit rate, but it is a rate of change. Now we're going to go on to question number 2. Find the rate of change from 20 minutes to 30 minutes. So 20 minutes to 30 minutes is this flat line here. Anytime you have a horizontal distance, there's no change in the rise. Even if there is a change in the run, you have a rate of change of 0. The elevation made no changes from 20 to 30 minutes. Now the last question is, what's the rate of change from 40 to 50? Well, here's 40, and there's 50. So let's take a look at the change along the y-axis. So we went from 5 all the way up to 25. So from 5 to 25 is a change of 20. And then from 40 to 50 is a change of 10. So our delta y is 20, and our delta x here is 10 minutes. So that's 2 over 1, also known as 2 feet per minute. And that concludes homework number 11.